Click New on the Action menu. Enter the name of your virtual machine. You will use this to identify the machine later. Use a naming convention to organize them. Select Generation 2 for generation of the virtual machine. You'll usually select Generation 2 for most of your installs, but if you're using any version of Linux or Windows XP or older, you'll select Generation 1. Enter the amount of startup memory you will need. This is the amount of memory that is allocated to the virtual machine when it starts. This is usually the minimum amount of memory you will assign to the machine if you're using dynamic memory, or the maximum amount of memory if it is not dynamic memory. Basically, you want to have the amount of memory that's assigned when it starts up be available for as the minimum amount. So if you have if you know you're going to run between 4 and 8 gigs of RAM for a machine, you'll assign 4 gigs of RAM for a startup. You might have a lower amount for the minimum, but you'll have the 4 gigs for startup. This will prevent you from over allocating memory to all of your guests, where the guests will stop working. I use a minimum of 2 gigs of RAM for each virtual machine to start and let it increase as needed. 2 gigs of RAM seems to be the minimum for Windows Server 2012 to install without slowing it down. This is what I found out on this host. Select a network connection that has internet access. My connection is named External. As the name implies, it will connect the machine to the internet. It will connect it to my router that has internet access. We will set up a secondary internal network connection later. We need to create a virtual disk. I found the minimum size for Windows Server 2012 R2 to run after updates is 20 gigs. You don't want to go less than 20 gigs. I am using the minimum disk size because I'm installing this farm on a solid state drive. Browse to the ISO of your Windows Server 2012 R2. If you do not select it here, you will need to manually add a DVD drive to the virtual machine later in the settings, and then select the ISO. This saves one step. Click Finish and Hyper-V will create the virtual machine. Change the settings from default to fit our requirements. Right-click on the virtual machine we just created and select Settings. We want to change the number of processors from 1 to 8, which is the maximum for this host. There's a debate about the right number of processors for a virtual machine and that having too many can actually slow it down. Admins would actually assign only a single CPU to a virtual machine, claiming that adding a second CPU would have no benefit. That was true 10 years ago, when overhead for a hypervisor was really high. Any person with current training understands that Windows is an operating system that can take advantage of multiple CPUs, and any benchmarking can prove it. This is important to do because the time it will cost you and the company is much more than the cost of assigning another CPU. In fact, installing and configuring Windows Server, SQL Server, and SharePoint on a farm with single CPUs assigned to the virtual machines will take 4 to 5 times as long compared to a farm with at least 2 CPUs. In the Microsoft literature, it clearly expresses the minimum number of CPUs, virtualized or not. For the automatic start action, I select nothing, meaning the virtual machine will not start if the host is restarted. This is usually set to automatically start this virtual machine. With a calculated delay in the case of a reboot of the host, it requires starting 20 to 30 virtual machines. Basically, if your host reboots and you have all these production virtual machines that need to start up and run, you don't want them all to start at once because you're going to max out your CPU and probably your disk arrays. So you'll kind of step them and time them. So one starts and then another based on usually disk I/O. The CPUs starting 3 or 4 at once really doesn't make a difference. For the automatic stop action, select Shut Down Guest. If the host is commanded to shut down, Hyper-V will send the shutdown command to the virtual machine or the guest so it can gracefully shut down. This means any processes or services running will try to finish or halt any processing in the way that it was designed versus shutting a hard shutdown. This means any services or processes running will try to finish or halt any processing in a way it was designed versus a hard shutdown, which can cause corruption. A hard shutdown can also be like just hitting the power button. So you're in the middle of a database write or something like that, you might mess up your data. Click apply and we're all set. We will set up the rest of the machines the same way, so you can skip to the next video if you like, or you can watch to maybe give me some more advertising revenue, or just kind of space out and watch me click. And that is it.